Hello everyone. From today we are going to start the some of the very important topics from organic chemistry. Organic chemistry. First of all, we try to understand the term reaction mechanism. In organic reactions, there are multiple steps are involving to complete the reaction. The overall process said to be as reaction mechanism. It involves breaking of bond of reactant molecule by applying thermal energy or light energy. H nu is the light energy, results the formation of highly reactive reaction intermediate which treat reacts with reagent finally converted into product. The overall process is said to be as organic reaction mechanism. Now, one by one, we'll define the entire process. First, we start with bond fission. What is the meaning of bond fission? It's simply defined as breaking of bond of reactant molecule. There are two processes are known or two methods are known. The first one is homolytic bond fission. Homolytic bond fission, and second one heterolytic bond fission. First one is homolytic bond fission and the second one is heterolytic bond fission, and the bond fission is carried out by applying thermal energy or light energy, that is H nu, one quanta of light or one photon of light. Now we'll understand what is homolytic bond and heterolytic bond fission. Start with homolytic bond fission. When the breaking of bond is taking place in such way so that each of the bonded atom acquire one single electron, said to be as homolytic bond fission. Let us consider A2 molecule, and these are one pair of electron being shared. Applying thermal energy, bond cleavage take place, and each of the bonded atom acquire one single electron, and these are known as free radical reaction intermediate. In this, both the bonded atoms are identical. We can consider Cl2 as an example, applying thermal energy and it causing the formation of highly reactive reaction intermediate called free radical. Free radical. Now what happens if the bonded atoms are different? Here you can see that bonded atoms are different. We consider methane as an example. Thermal energy is applied. H3C, and there is one electron on this carbon. This is methyl free radical. Methyl free radical. So, homolytic bond fission clearly explained by me, and now the next part of the bond fission, that is heterolytic bond fission. What is heterolytic bond fission? When the electronegativity of the bonded atoms are not identical, in that condition, the more electronegative atom acquires total shared pair of electron of that bond and breaks down and form charged ion. In this, X is more electronegative than C, and in this example you can see that the carbon atom acquiring positive charge, it is known as carbocation. In heterolytic bond fission, always charged ions are formed. Now, next topic is reagent. What are reagents? Reagents are the species which are responsible for the chemical reaction, classified into two parts: electrophilic reagent and nucleophilic reagent. Electrophilic reagents are represented by the symbol capital E and nucleophilic by Nu. Electrophilic means electron loving. So all the electrophilic reagents definitely electron deficient species, and nucleophilic reagent represented by Nu, one shared pair of electron and negative charge. It is electron rich in nature. So here we can see that reagents are of two types: electrophilic reagent and nucleophilic reagent. Now, the electrophilic reagent further classified into two categories. First one is charged electrophile. All the positively charged ions like R plus, RCO plus, NO2 plus, etc. are the example of charged electrophile, followed by neutral electrophile. These are electron rich but do not possess any charge on them. Beg your pardon, neutral electrophile. These are electron deficient, possesses no charge on them. like AlCl3, beryllium chloride, etc. So on. Nucleophilic reagents further classified into two categories: charged nucleophile, all the negatively charged ion like Cl minus, OH minus, RO minus are the example of charged nucleophile. Next, neutral nucleophile has no charge but are electron rich. The covalent molecule in which central atom has lone pair of electrons like water and ammonia. These are neutral but are electron rich, and therefore they are categorized as nucleophilic reagent. I hope that this part is clear to all of you. In the next part, we'll discuss different types of reaction intermediate. Till then, thank you and goodbye.